Hello, y'all. So today I'm going to just be doing another sudoku. So yeah, I guess with that said, we'll get into it. So this is 6 by 6 instead of a standard sized one. And it's an irregular grid with, let's see, just run-bound lines. So yeah, okay. So immediately looking at this, these 3 digits here have to be the same as these 3. And I can do the same thing with these. Okay. Let's see. These 2 digits have to be consecutive, so it's either 1, 2, or some group of 4, 5, and 6. Which isn't super clear, actually, now that I've said that out loud, thinking about it. Okay. Let's see. So, one of these 3 is a 6, and one of these 3 is a 6 as well. Okay. I'm just trying to determine if this information is actually all that helpful to get 6s and 3s placed. Let's see. So here we have 2 groups of consecutive digits, each of which has to include at least one of 3 and 4. And same thing with this group, actually. It has to be 4, 5, and 6, since it can't have a 3 in it. Which means that this group here has to then be 1 and 2, this one here has to be 4, 5, or 6, and these 2 are the same number, which must be in one of these 2 cells, and in one of these 2 cells. Which means that if it's in the red group, it's up here, and if it's in the yellow group, it's in one of these 2, which that's a little bit more information than I would like to have, so I'm not actually going to mark that yet. Let's see, this one here is 4, 5, and 6. If this doesn't include a 3, let's consider that case first of all. Then I'll just mark this as, then these 2 are the same digit, and these 2 are the same digit, right? Because if there's no 3, then that's just how it has to be. Then I get that this would be the same digit, and this would be the same digit. And from that, this one here has to be, pink. So one of these 2 would be pink. One of these 3 would be a black one. And actually one of these 2. Okay, let's see. And what that also means is that, based on that, right, we also know that this one has to be pink because both these rows are seen, which means that one of these 2 is pink. And similarly for black, one of these 2 would have to be black. That doesn't seem actually really to break, thinking about it, so I'm gonna scrap that for the minute. Okay. Let's see. Well, this one here does have to be 4, 5, or 6. And it can't be yellow, so actually this one, I guess I can mark as being the same as that one. And it has to be one of these 2, I suppose. Okay. And then this one here is 3 or this. So I guess it's 3, 4, 5, or 6. So, let's see. Alright. From that, let's see, I'm just trying to figure out where I actually want to go with this now. Well, since 6 sees all 3 of these, one of these has to be a 3. It's unclear as to whether it's 3, 4, 5, 1, 2, 3. Or I guess even 2, 3, 4 is possible because this one would just have to be 2 or 4. But yeah. Theoretically, this one could include a 3 or not. Not super sure at the moment whether it actually does. Let's see. If this one has a 3, I guess it could be in any of these 3 cells, and it shouldn't break anything, I don't think. At least I don't... no, well, it can't be here, actually. So I can't have a 3 here, it'd have to be in one of these 2. Because if I have a 3 here, then this one also needs to be a 3, and that's going to break this group of cells down here. So, yeah. Okay. Let's see. Then one of these 2 is a 3, or this is a 6. Okay, I don't think that's going to get me anywhere really at the moment. If this is a 3, then I just have a 3 up here. One of these 2 is a 3. And I don't think that dramatically changes much of anything. Just thinking about it. One of these 3 has to be a 6. If either of these is a 6, then both of those are 6s. Yeah, so let's see. If we have a 6 here, we get 2 6s in both of these spots. Does that do anything? I don't really think so, actually, just thinking about it. Or at least I don't think it does anything super useful. Okay. Can either of these be a 3? I don't see why not, looking at it. Which means that I don't necessarily need to have a 3 here. Yeah, okay. Alright. Let's... Yeah, I'm just trying to find where to go now with this. Because this cell here could be this one, or it could not. If this is a 6, then this one doesn't need to be a 6 as well. If this is 4 or 5, if one of these 2 is a 6 instead, then this would have to be a 4, but that's not necessarily the case. Let's see. If this one is 4, 5, or 6, and it lines up with the pink one here. So let's see. If this is pink, then we get this one is pink, and one of these 2 is pink, and one of these 2 is pink, which I don't think is an issue. Just thinking about it. At least I don't see an issue with that. This one, I guess this one can't be black, which I'm not actually going to keep that marking because it's pretty much completely meaningless. I should get rid of these 2 as well. Let's see, this 6, one of these 3 does have to be 6. If it's the yellow ones, then we get a 6 here. And, let's see, one of these 2 would be a 6, and this one would be a 6. So we just get that, which I don't think there's an issue with. If this one is 6, then, let's see. Right, we have a 6 here, then, this is a 6, that's a 6, this one's a 6. These both have to be the same digit, which I don't think causes an issue, to be honest. Okay. Just trying to find any way to break this kind of pattern. I'm just not seeing a way to, though, is the problem that I'm running into with this solve currently. Well, actually, this digit here has to be pink, right? Because it can't be yellow or this one. And it can't be a 3, so this one just is guaranteed to be pink. Thinking about it. Which means, one of these two is also going to be pink. Let's see. So if it's, if this one's pink, then we get a pink here, which is going to make one of these two and one of these two pink, which means we get this pattern. That's one hypothetical, and I guess I'll do black for the other one. If we have this pattern, we get that one of these two, and then one of these two. No, wait, no. Yeah, one of these two, one of these two, yeah. Okay. So those are the two options for this. In either case, these two are guaranteed. Let's see. If both of these are pink, then that implies it's not 6, it's 4 or 5. Which means that this one here has to be 3, 4, or 5, right? Yeah. Then this one would be 3, 4, 5. We have a 4 or 5 here. This one would have to be also 4 or 5 or 3, so we'd have a group of 3, 4, and 5 for these. So then these two would have to be 1 and 2, and this would have to be a 3. And then over here we would also have 4 or 5. Which breaks because of the pink one here that has to be 4, 5, or 6. So the pink case I don't think is actually possible, but just to check. This one, if we have the pink case, we get something of the group 4 and 5 in all of these. Right, then this one has to be 3, 4, or 5. And this one here, since I have a 4 or 5 here. Let's see, if I have a 4 here, this one actually could be 2 as well, thinking about it. Right. Let's see, if it's pink, I can't have 5. Let's see, if I have 5, then I get 4 here, and this one has to be 3, and so I can't have 5, it would have to be 4s. In which case, this one here is 3 or 5, this one here has to be, it can't be a 5 because then I would have a 3 here. This one also can't be a 5, so it must be 2 3s, 2 and 3. And that would just make, neither this one would have to be a 6, which would mean that one of these two, I guess, would be a 6, but it's unclear which. Either way, I think all that means is this one has to be a 5. Then we get 1, 2, 3, 1, 2, 3, 1, 2, 3 for these groups. Well, that one has to be 2 or 3, actually. That's a 4 here, which makes this one could potentially still be a 3, I suppose. This one here has to be 1, 2, or 3. This one here would have to be 1, 2, or 3. That would be a 6. And then, let's see, I have a 4 here and 5 there, which would also actually break. So that's why it would actually break. So pink is not possible. Just jump back a long time to before I pencil marked in all this stuff. Okay, so I can't have the pink case, so that tells me is that, okay, get all of these and then one of those two. I'm going to switch it over to being pink because that color is more visible to me. Alright. Okay then. Which means that this one here, which I guess is going to be blue, Where else can... Well, this one here also has to be 4, 5, and 6, actually, so I can just mark 1, 2, 3 in these. That means the blue one also has to appear in one of these 3, and in one of these 3. I don't think that actually goes anywhere thinking about it, so I'm going to just temporarily get rid of all the blue, because it doesn't seem super useful. Okay. Alright, well, one of either these two are pink, or these two are pink, which means either way one of these two cells has to be a 3, 4, 5, 3, 4, or 5 to match with this, which is not actually that helpful. There's just not that much information from that you can really use, just thinking about it. Maybe I will go back to this and just say, hypothetically, what if it's the red one? Then one of these two has to be blue, one of these two has to be blue, and something in this clump has to be blue, so that's actually not helpful. What if it's this... Alright, if it's this red one, it could actually be either of these. Thinking about it, so let's go with, what if it's this green one here? That's also not helpful, so once again I'm going to drop that because it's just not helpful. Well, actually, first of all, I have a 1, 2, or a 3 here, so I can't have a 6 over there. These ones max out at 5, I suppose, which that's not helpful to mark, but oh, that does mean there is a 3 in here guaranteed as well, which means it can't be in that one, and now this one also can't have a 3 because it would see both of the other two, and this one can't be a 3, so okay. There we go, that's something. One of these 3 is a 3, I suppose, although I guess it's technically one of these 2, actually, so I got no 3 in the red one there. This one theoretically could be a 3 as well. So yeah, it's one of these 2 is a 3, one of these 2, one of these 2, one of these 3, and one of these 2 are a 3. Okay. If this one's a 3, this one could still be pink, I suppose. Actually, no, it couldn't, because this one's only pink if it's a 6. So if this is a 3, then these two have to be pink. 4 or 5, and then this one also has to be 4 or 5. Because it can't be a 3, and this one here is 2 or 4, I suppose, and we have a 3 here, a 3 here. Then this one is blue, which means this one has to be a 2 because it can't be any of the 3 colors in that case. Let's see. Yeah, both of these are 3s. Okay, This one here theoretically could still be 4, 5, or 6. It doesn't necessarily have to be 1, 2, or 3, so I can't really narrow anything down with that yet. Let's see. If this one is 1 or 2, then this one has to be 1, 2, or 3. Which, I guess this one also could, either of these suppose, actually not that one. This one theoretically, I guess, could be a 3. No, it can't, for the same reason that the other one is, that this one isn't a 3, it sees both of these. So, yeah, one of these two does have to be a 3. If I have a 3 here, then I get a 3 here, 3 here, here, and here. All of that works. And, nothing really breaks because of that. Let's see, is there anything more specific I can get with yellow, other than knowing it's one of these 3? Because, like, yeah, for this row, it could be any of these 3, I think. If the yellow is this one, I suppose, then this has to be a 3. And this one's yellow, so then this one has to be yellow as well, which means this one's a 3, and then this one's either 2 or a blue. That doesn't, I don't think that breaks or really does much of anything. Oh yeah, this one, these two are then both yellow. Right? Yeah. Am I right? Oh wait, I think that does actually break something, right? Because if this is yellow, then reds need to be yellow. But then every square is seen by these, so this one can't be a yellow actually, so it has to be one of these two. Oh, if it's this one, then we get that this one has to be yellow, which breaks down here. So this one's actually going to be the yellow one, which means that something in this box is yellow. And can't be this, well, depending on if it's green, this one has to be yellow. If it's red, this one has to be yellow. So it's actually one of these two, which means that, yeah, okay. So now we have that at least. If pink is 6, then yellow has to be 4, right? Because this has to be a 5 here, and that sees this, so that's why. Okay, and if pink is not a 6, then it's in these two, in which case this is this one can't be a 3, so it would have to be blue. So either way, one of these two is blue, right? Because one of these two is pink, and yellow's already been determined to not be in either of these. So then, let's see, one of these two is a blue one, which means that this one here has to be 1, 2, or 3, which means that, yeah, if this is yellow, then this is obviously just a 3, and then that would imply yellow has to be 4, right? Because if yellow's 5, then, actually no, that doesn't imply that, because yellow could be 5, this one could be blue still. It would just mean that pink would have to be 6. So, one of yellow and pink has to be 6 then, right? Because if neither of them are, then that implies this one here has to be, no, this one could be a 4 and then a 2, and then we have 6 and 5. So that does work, actually. If, no, wait, if neither of them are 6, that doesn't work. Yeah, one of the two has to be a 6, right? Because if neither of them are 6, then we have all 3 of these actually need to be valid, so that breaks, which means one of these two is one of these two here is a 6, which means this one's 4 or 5, which means this one has to be 4 or 5, so this one does in fact actually have to be blue, which means that this one is blue, which means that this one is blue, which means that this one up here is blue, so this one has to be pink, which means we get our yellow, which, surprising not me in the slightest, because I kind of figured that we were going to get something like this. The diagonal is going to hold all 3 of them. It just felt right for a pattern, I suppose. This one's 4 or 5, this one's also 4 or 5. Let's see, and then yellows are 6s. And this one should be here. Okay, and then here's the other blue 4, 5. So this one can't be 1, it has to be 2 or 3. This one here also has to be 2 or 3. Right, because it can't be, if this is 5, neither of these can be 4, so that breaks. Therefore, this one has to be 4. And all the pink ones have to be 5s. So we get a 2, 3 pair here, so this is a 1. Here's another 2, 3, then this is a 1. Just another 2, 3 pair. 1 here, which is going to give me pretty much the whole pattern, I think. Actually, I think it's just, yeah, there we go, okay. Definitely enjoyed that one. It's, you know, sometimes it's nice to do a non-fog of war, smaller one. Because, like, the logic in this, definitely very interesting, very hard to find. So, yeah. Alright, thanks for watching, and I'll see you all next time, I guess, so bye.